That's going to be a fairly tough one to calculate, but look at this here. Aren't we able to calculate theta, which is the big angle? Let's call that one theta. We can calculate theta, and we can also calculate beta. Now beta is the angle sort of from the horizontal up till BC. That is beta, and the angle theta is from the horizontal all the way up to AC. Both of those angles can be calculated using gradient. If I subtract the big one or the small one from the big one, won't I be left with alpha? Let's start off by calculating theta. Theta, remember, a gradient m is equal to tan theta. So let's start by looking for m of AC. Gradient of AC is y2 minus y1 over x2 minus x1, which is equal to 4 minus 0 over 3 minus minus 5, or 3 plus 5, which is equal to 4 over 8, which is equal to 1 over 2. My gradient of BC is going to be given by, again, y2 minus y1. In this case, it's going to be 2 minus 0 over 4 minus minus 5, or 4 plus 5, which is going to equal 2 minus 0 is 2, 4 plus 5 is 9, 2 over 9. Now remember, I know that m is equal to tan theta. Now that big angle theta is equal to second function tan of the gradient of AC. Gradient of AC, the second function tan of that, will give us theta, which is equal to second function tan of a half, which is equal to 26.6 degrees. Beta, on the other hand, let's do that in another color. Beta is given by tan, second function of the gradient of BC. That will be second function tan of 2 over 9, which is equal to 12.5 degrees. So I've got my small angle of 12.5, I've got my big angle of 26.6. That means that alpha is equal to 26.6 minus 12.5, which is going to give us an answer of 14.1 degrees. That is what alpha is equal to. That small angle in there is equal to 14.1 degrees. Now in the second question that I gave you to do, we are looking for, the first bit says that find theta, and I don't give you any other information. Now the problem with that is, how do we find theta? If C and A, or rather A and AC, is not parallel to the x-axis, we can't find theta simply by looking at the gradient of AB. However, look at the y value of A. The y value of A is 1, and the y value of C is also 1. That means that AC is parallel to the x-axis. Because AC is parallel to the x-axis, it means that theta, the angle CAB, that angle over there, is going to be the angle of inclination of AB from AC. But only because AC is parallel to the x-axis. Now theta, remember that m is equal to tan of theta. M of AB is equal to y2 minus y1, which is 5 minus 1, over x2 minus x1, which is 4 minus minus 2, which is equal to 5 minus 1 is 4, 4 minus minus 2 is equal to positive 6, because that's 4 plus 2, which is the same as 2 over 3. That is my gradient of AB. But we know that tan theta is equal to my gradient. That means that theta is equal to the second function tan of my gradient, which is 2 over 3. Second function tan of 2 over 3 is equal to 33.7 degrees. That means that theta is 33.7 degrees. The second bit of the question said determine M, the midpoint of AB. Now to get the coordinates of M, to get the x coordinates, I'm going to say x2 plus x1, which is going to be 4 plus minus 2 over 2, and the y coordinate is going to be given by y2 plus y1, 5 plus 1 over 2, which is going to be the coordinates of M. 4 minus 2 is 2 over 2, 5 plus 1 is 6 over 2. That means that my coordinates of M are 1 and 3. The third bit I gave you to do read, determine the distance of CM. Determine the distance CM if AB is equal to AC. Now there's a reason I told you AB is equal to AC. Can we use the distance formula to get CM? No, we can't. The reason being is that we don't have both coordinates of C. We have to first calculate the x coordinate of C, and then we've got two sets of coordinates from which to calculate our distance. But we do know that AB is equal to BC. AB is equal to BC. Now AB is going to be given by x2 minus x1 squared plus y2 minus y1 squared. Oh, sorry, not AB. I said AC is equal to BC. My x coordinate of C is just x for now. If AC is equal to BC, let's look at the distance AC. x2 minus x1, minus minus 2 is plus 2, squared, plus y2 minus y1 squared, and the square root thereof gives us the square root of, to get BC, x2 minus x1, which is going to be x minus 4 squared, plus y2 minus y1, which is 1 minus 5 squared. Now because both sides are in the square root sign, I can simply square both sides to get rid of the square root. That means that this side reads x squared plus 4x plus 4. 1 minus 1 is 0. X squared minus 8x plus 16. 1 minus 5 is negative 4 squared is negative 16.